In this video, we'll look at question 84 from the 2017 exam. In this question, we'll look at a stone which is being thrown right up into the air vertically with an initial speed of 13 meters per second, and it goes up and then down even below that cliff, 6 meters tall. So 8 is level, at the height from which it was first fired, and B is the bottom. The question is how long it will take for this stone to travel from A to B. So this will be a useful SUVAT formula for us to use. Before we get to that, we can make our life a bit simpler by realizing that as it passes this level A for the second time, so after it has been fired from the cliff, it will do so at a speed of 30 meters per second, the same as before. And I encourage you to stop the video and think about why that might be. A good explanation for that is that the energy has to be conserved throughout. And since these two instances, the one stone, has the same potential energy, the kinetic energy has to be the same. And if the kinetic energy of the same object is the same at two different instances, that means that their speeds have to be the same. They're just in opposite directions. Now that greatly simplifies our situation, because now we have a stone which starts off at 13 meters per second, then travels for 6 meters while being accelerated by gravitational acceleration. So if we plug that into our formula here, so we get 6 meters for s, then the initial speed is 13, and gravitational acceleration, that's 10 meters per second, which yields a nice quadratic equation. And if you use your preferred way of solving a quadratic equation, this one you probably can't easily factorize, but if you use the discriminant, you'll see that one solution is 0.4 seconds and the other one is minus 3 seconds. Of course, as usual in physics, we only are interested in the positive solution, so I'll cross out the negative one. So it takes 0.4 seconds to get from A to B. That's our final answer, and in the exam it was option A.